Welcome to today's video. We're diving into the importance of training, validation, and test sets in machine learning. These datasets play a crucial role in ensuring models are reliable and generalize well to unseen data. Let's get started. Here's the outline of what we'll cover. First, we'll define training, validation, and test sets and understand their purpose in machine learning. Then, we'll explore how to create these datasets and choose appropriate split ratios. Finally, we'll see how to use Python to split data into these subsets. By the end, you'll know how to effectively manage data for machine learning tasks. In machine learning, data is key to building models that make predictions. Data consists of instances, which may be labeled or unlabeled. Labeled instances include features and an output label, while unlabeled instances don't. Splitting the data helps prevent overfitting and ensures the model performs well on unseen data. Let's talk about the role of each dataset. Training data is used to fit the model, allowing it to learn patterns. Validation data helps optimize the model's performance, tune hyperparameters, and conduct feature selection. Test data is reserved for evaluating the final model's performance and comparing different models. It's important to ensure the data distribution is similar across these subsets. Choosing the right data split ratios is critical. Typically, 60% to 90% of the data is used for training, 5% to 20% for validation, and 10% to 30% for testing. The exact ratios depend on factors like the size of the dataset, model complexity, and error measurement methods. Larger datasets allow for more flexibility in these splits. Python makes it simple to split data into training, validation, and test sets using scikit-learn. By calling the train-test-split function, you can divide the data into subsets with specified proportions. For example, you can first split data into training and temporary sets, then further split the temporary set into validation and test sets. This process ensures you have the right subsets for effective model evaluation. Properly splitting data is essential for preventing overfitting. Validation data helps ensure the model generalizes well during training, while test data provides an unbiased estimate of how the model will perform on unseen data. These splits are fundamental to building robust and reliable machine learning models. To summarize, splitting data into training, validation, and test sets ensures models are reliable and perform well on new data. Each dataset serves a unique purpose, from fitting the model to optimizing it and finally evaluating it. Tools like Python's scikit-learn make this process easy and efficient. Thanks for watching. If you enjoyed this video, please like, share, and subscribe for more content on data science and technology. See you next time.